Alright, welcome. We're going to continue on with Chapter 2 in Section 8 and talk about proportions and similar figures today. Our objective is going to be to find missing lengths in similar figures and use similar figures when measuring things indirectly or using indirect measurement. Alright, there's a lot of cool things that you can do with similar figures and cool activities, and we're going to get started with them today. Okay, so first we got to just examine what exactly a similar figure is. Similar figures have the same shape but not necessarily the same size. Okay, so we've got triangles that may have that exact same shape and not the same size, or rectangles that have the same shape but not the same size. In similar figures, all our corresponding angles are going to be congruent. Okay, so the word that we'll put here is congruent. Congruent. Meaning that if we're dealing with rectangles, obviously they all have to be 90-degree angles. Once we get into triangles and trapezoids and that sort of thing, their angles would have to be the exact same thing in each figure. Okay. Corresponding side lengths, however, in these cases are going to be proportionate. Proportionate. Meaning if we were to compare the ratio of the smaller side length to the bigger side length, it's always going to be the same ratio, or that same fraction, when we simplify things down. Okay, so in this case we've got a 4 to 6. Okay, we'd compare that to an 8 to some number, and that would have to be the exact same thing. Alright, same number. So proportionate. Let's just jump in and talk about corresponding angles and sides first, so we know exactly what those are. Alright, in this case we've got triangle ABC, which is similar to triangle DEF. This little squiggly line just means similar. Okay, so if these two are similar and we're trying to come up with corresponding angles, again, those are kind of in the same position, and we can see that angle A and angle D, we've got the note or the denotation that says that those two are the exact same angle, so those would be corresponding angles in this case. Alright, so our angle A is congruent to angle D. Right, we've got two other congruent angles or corresponding angles. Angle B and angle E would be corresponding. Angle C and angle F would be corresponding as well, because they are in the same position, they've got the same angle measure, so those are corresponding angles. Right? Corresponding sides, again, we're looking for the same position. We've got angle AB, and if you notice, these things are going to go in order. We've got AB is going to be congruent or corresponding to DE. Right? BC will be corresponding with EF, and so on. DF will be corresponding with AC. So we'll just mark down a couple of those. AC, we'll say AC, side AC is corresponding or congruent to DF. Okay? So once we get that down, we know what our corresponding angles and corresponding sides are, we can actually go in and start solving some of these similar figure type problems. Right? If we're working with that same triangle and we wanted to find this length, we want to find the length of A to B. Okay? And we are going to use the fact that these are similar figures to solve for that length. Alright? And we can basically use any side lengths that have the exact same corresponding sides in both figures. So in this one, BC and EF, those are two corresponding side lengths. We're going to use that since that ratio is going to be consistent, or the ratio of the side lengths is proportionate. Okay? So we're going to just call this value X. Okay? And we're going to compare the smaller over the bigger to the smaller over the bigger. So what we do is we say from A to B, that's X over the corresponding side length of 10. So X over 10 has got to be equal to our smaller to our bigger, or 12 to its corresponding side length, which is 16. Now notice we could solve for the side length of DF as well. Alright, we'd use this same ratio, or we'd use the ratio of B to C over E to F, alright, since that's the one that we know. Okay? And from there, all we need to do is just play baseball, right? We play baseball, we multiply 12 by 10, and we divide by our 16. Okay? Our answer for X should be equal to 12 times 10, which is 120 over 16. Okay? So again, since these side lengths are proportionate, we can use the fact that we know the smaller to the bigger to solve for an unknown side length. Okay? X equals 120 over 16. We would simplify that down. Looks like it should get us to about a little bit over 7, alright? A little bit over 7 for a side length there. Okay. Let's take a look at a second problem here. Solve these, or use these similar figures to solve for the side length of x. Okay. Now we know that x is the smallest side. Over here we've got the smallest side of 4 inches. So those two are your corresponding sides. All right, corresponding sides. So we're going to use that and say, all right, if x over 4, okay, or the, looks like the smaller over the bigger. And now we need to pick what other smaller over bigger combination we want to use. And I think 6 over 15 would be nice because those are both integers. Alright? So let's say x over 4 is equal to 6, which is the smaller side, over 15. And from there, again, we play baseball. Alright? We multiply 6 by 4, which gets us to 24, and we divide by the ball. Right? So divide by the ball. Our answer should be 24 over 15. X equals 24 over 15, and that simplifies down to about, let's see, 1. And then we've got 9 left over, so about 1 and 9/15. Ooh, it's feedback. All right, about 1 and 9/15 simplifies down to, if we divide both sides by 3, we should get down to 1 3/5, okay? 1 3/5, or about 1.6, which would make sense, all right? If you check your reasonableness, that would make sense, okay? Now, other things that are really nice with these similar figures that we can use is what's called indirect measurement, or using measurements of other objects to figure out exactly how tall something is just by using simple calculations. Okay, so let's say a man who is 6 feet tall is standing by a flagpole. That man's shadow stretches 3.5 feet from his feet, and the flagpole's shadow stretches 17.5 feet from its base. And we're asked, how tall is the flagpole? Okay, so in this case, we've got a flagpole here. We're trying to solve for the height of the flagpole, or how tall that thing is. All right. Now, if you think about it, the angle of the sun is going to be consistent. The angle is always the exact same thing coming down like this. Alright, so if we've got the similar angles, you notice it forms basically 2 similar triangles, alright, where the shadow is the base of the triangle in each case, alright. The length on this side, it's not as important, that's just the kind of the angle of the sun, but your angles are all the same too. So we've got 2 triangles that are formed, they're both right triangles, alright, one being a little bigger than the other, alright. And the 2 triangles, again, are right here and right here. Okay, so now we can just plug in some values that we know. We know that the shadow of the man is 3.5, and he is 6 feet tall. The shadow of the flagpole is 17.5, and we're looking for the height of our flagpole. Okay, so again, we're going to compare the smaller to the bigger based on what we know, and set that equal to the smaller over the bigger, which is what we're trying to find out. Okay, so we're going to say 3.5 over our bigger value, which is 17.5, is equal to, well, the smaller in this case is 6 over our variable of x, kind of bad x. Okay, so 17.5. We're going to multiply this by 6, or play baseball, alright, solving proportions, 17.5 times 6, and divide by our ball of 3.5. Okay, 17.5 times 6, that gets us to 6, about 105, alright, right around 105. For 6 times 17.5, so we have 105, and we're dividing that by 3.5. Okay? Which again, that's just computation, that's just getting to the point where we're just dividing. Okay? This value is equal to the height of our figure. Okay? 105 divided by 3.5 gets you to right about 30, right? X should be equal to 30 feet. Okay, so again, we're using that fact that we've got a similar figure that's formed, and we're going to solve for the unknown value. Now, I know we've been working a lot with scale drawings as well. That's a great time to use proportions to solve for unknown sides as well. Alright, so scale drawings, again, this is just a key vocab term. Scale drawings, good things to include in there: floor plans, blueprints, maps, etc. They all use what's called a scale, alright? And a scale is just a ratio of the length on a drawing to an actual length. Okay, so a length on the drawing to the actual length. In this case, with this map, I know it's kind of small to see, the scale is 1 inch for every 110 miles. 1 inch for every 110 miles. So if we let x be the distance from Jacksonville to Orlando, right? The distance from Jacksonville to Orlando, okay? We know that our scale is 1 inch for every 110 miles, right? We're looking for our actual miles, okay? Actual miles. In this case, it looks like our 1 inch, it's about 1.5 inches, right? 1.5 inches, so 1.5 inches. So again, we're just setting up multiple proportions, right? And then we're cross multiplying and dividing or playing baseball, right? 1.5 inches times 110, eventually we'll divide by just that inch. So basically all we're doing is 110 times 6, or times 1.5. Okay, 110 miles times 1.5, which gets you to, let's see, 110 times 1.5. Half of 110 is 55, so 55 plus 110 should get you to about 165 miles. Okay, again, all we're doing is setting up proportions, right? Multiple proportions. All right. Last examples here. Let's say the scale of the map is 1 inch for every 20 miles. Find the actual distance. All right, again, this one's a little bit easier if we know 1 inch is 20 miles. Basically, all we're doing is multiplying 3.5 times that 20 miles. Okay, 3.5 times 20, 3.5 should get you to about 60. Half is 20 is about 70 miles in this case. Okay, if we multiply. B, 12 inches, we were saying 1 inch is 20 miles, so we're just taking 12 times 20 in this case. 12 times 20, which gets you to about 240 miles. Okay, and that is it for section 8. We'll work more with it tomorrow. Thank you.